Alkynes, nomenclature and structure of alkyne, that means acetylene, sp hybridization you already studied. Next point is methods of preparation. I hope all of you know the chemical formula. Please write the chemical equations. Balancing you can do it later. 1. From calcium carbide. Acetylene is prepared in the lab as well as it is manufactured by the action of water on calcium carbide. Write the equation. Calcium carbide reacts with water and forms calcium hydroxide and acetylene. Second method of preparation, from natural gas. Natural gas, which consists of mainly methane, is also used for the manufacture of acetylene. Write the equation. Methane is heated at a temperature of 1773 Kelvin in an electric arc. Acetylene and hydrogen are formed. Third method of preparation, dehydrohalogenation. The meaning is removal of hydrogen and a halogen. Therefore, a vicinal halides, from vicinal halides, which is the chemical formula is given here, RC halogen group and halogen group very close to each other. Next carbon atom, H, and fourth valency of this carbon is satisfied by H. This is a general formula of a vicinal halide. When it is treated with alcoholic KOH, what happens is that each halogen is eliminated as a hydrogen halide. For example, in order to understand how the elimination of HX, the structure of vicinal halide can be written like this also. That is RCX. Next to it hydrogen. That means this hydrogen is placed here, so that HX is eliminated. Similarly, here there is already an H. This X can be written here, so that another HX molecule is eliminated. And an alkyne of the formula RC triple bond CH plus 2 molecules of hydrogen halide is obtained. This is the general representation. Now comes application level questions. How to prepare based on this. 1,2-dibromoethane. Write the formula of 1,2-dibromoethane when treated with alcoholic KOH gives acetylene, potassium bromide and water. The use of KOH gives rise to side reaction. Therefore, dehydrohalogenation is usually carried out with sodamide. Formula NaNH2. Therefore, you have to write another equation with sodamide instead of alcoholic KOH. 1,2-dibromopropane. When treated with sodamide, the products are propyne. You must know the formula of propyne, sodamide and 1,2-dibromopropane. The sodium bromide, propyne, sodium bromide and ammonia are formed. Write the equation. Next is dehydrohalogenation of 1,1-dihalide. That means on the same carbon atom the halogen group. The first one, what is vicinal halide, very close to it, carbon carrying halogen like that. But this now on the same carbon atom, if two halogen groups are there, 1,1-dibromopropane when treated with alcoholic KOH, propyne and hydrogen bromide are formed. You must know the formula of 1,1-dibromopropane. 1,1-dibromopropane when heated with alcoholic AOH, propane and hydrogen bromide are formed. Now fourth method, electrolytic method, that is Kolb's electrolytic method. This method is used for alkanes, alkenes and alkynes. It is a comparative study. That means in alkanes it is a simple compound sodium acetate is used, but here second in alkenes it is a single bond compound, that is sodium succinate is used. Now we are going to use a double bonded starting material, that means potassium malate. Formula CHCOOK double bond CHCOOK. First ionization forming CH double bond CH. The double bond should be put between the carbon atom. Don't put the double bond anywhere here below H or below this C or below this O. It is wrong. And ions and potassium ions are formed. Minus ions goes to the anode and eliminates the excess electron. 2 molecules of carbon dioxide and acetylene is formed. Now in the cathode, which is negative, the positive ions goes, accept 2 electron, get converted into potassium. Potassium is highly reactive. It reacts with water and form potassium hydroxide and hydrogen. Now comes physical properties of alkanes. There are 4 physical properties are mentioned in the textbook, page number 782. Please refer and write the notes in your notebook.